I hope everybody had a happy Thanksgiving and is ready to get back at a new unit. This unit's going to be on radicals and rational functions, radical functions and rational functions. We'll start off with the radical functions. Here I have my parent function of the square root of x, and that's here the graphed in red, and a couple of points on here, 0, 0, of course, square root of 0, 0, square root of 1 is 1, so 1, 1. Square root of 4 is 2, so 4, 2 is a point. 9, 3, square root of 9 is 3, here's 9, 3. There's a point on the graph, and square root of 16, 4 would be right up here. So those are important points. It's always over 1, up 1 for the parent function, and over 2, up 4 for the parent function. Now, if you have the number out in front, as this blue function does, you can see it increases at a very high rate. Number inside, it increases at a high rate, but not quite as high as being outside. And if you think about it, if I plugged 1 in for x, I'd get 5, and here's 1, 5. And here, if I plugged in 5 for x, I'd get square root of 25, which is 5, and here's 5, 5. So the blue one, you can find that point, that's 1, 5, and this is 5, 5. So you can see how it increases from the parent function. Now let's look at when we put some negative signs in a couple of different places. Again, here's our parent function, the square root of x, and its domain is all of the x values greater than 0 and all of the y values greater than 0. And when we put the negative sign out in front, that changes the y values to negative. So my x values are still positive, but my y values become negative. And if the negative is inside or underneath the radical sign, it's the x's that become negative, and the y's stay positive. And as we've seen with other functions, when we add something either outside or inside, it changes the location of where it starts. And here we've got again the parent function with the domain and range of x greater than or equal to 0 and y greater than or equal to 0. And if I add something outside, it is going to make the graph go up 3. In this case, the y values now are greater than or equal to 3. It changes the range, because the y value is changing. And if it's inside, then it's the x value that's changing. That's where it's closest to. It's the x value that's changing. In this case, it's the opposite, and it's going to the left 3, and therefore my domain changes to be the x's greater than or equal to negative 3. So again, inside is left and right, outside is up and down, and the inside, left and right is the opposite of what you think. The up and down is exactly what you think it is. And just a quick note, you can find this x value of where this tail starts by solving for what's underneath the radical, because what's underneath the radical has to be a non-negative number. We cannot take the square root of a negative number, so it has to be a positive number. So what's underneath the radical has to be greater than or equal to 0. So in this case, x plus 3 is greater than or equal to 0, which means when I subtract 3 from both sides, that x has to be greater than or equal to negative 3. And here you can see this tail starts at negative 3. So if you're given a radical function to graph, you will start with the function. Here's my function, y equals negative 2 times the square root of 2x plus 3 minus 4. You're going to start with what's underneath the radical because you know it cannot be a negative number. So it has to be greater than or equal to 0. So here's 2x plus 3 greater than or equal to 0. And when I solve that by subtracting 3 and dividing by 2, I get x greater than or equal to negative 3 over 2. So that's negative 1.5. And you can see here my tail starts at negative 1.5. So what we're going to do, then you're going to look at the x values that are bigger than negative 3 halves, which are negative 1, 0, 1, and 2, and you'll plug those into the equation, negative 2 times the square root of 2 times x plus 3 minus 4. So when I plug in negative 1, I get negative 6. When I plug in 0, I get negative 7.5. When I plug in 1, I get negative 8.5. And when I plug in 2, I get negative 9.3. And so I then can graph those 4 points. There they are, negative 1, negative 6, 0, negative 7.5, 1, negative 8.5, and down here just off the graph would be 2, negative 9.3. We can find the range of this function by looking at the negative sign out front and the negative 4 that has been subtracted here at the end. Since this is a negative sign, it's going to be less than or equal to, and that negative 4, and you can see here's negative 4, and my y values are less than negative 4 or below negative 4. So this vertex point is negative 3 halves, negative 4, and that's the fifth of the points that you can graph and you can find to graph for this radical function.